Quick review. So your test is going to cover 4.1, 4.7. So 4.1, you need to know complement and supplement. You need to know coterminal. So complement, you're subtracting from 90 or pi over 2. Supplement, you're subtracting from 180 or pi. Coterminal, you're adding or subtracting 360 or adding or subtracting 2 pi. You need to know arc length, which is that SOR. S equals theta times the radius, where theta has to be in radians. So I'm going to give you back your quizzes, but biggest mistake made on those was that. Leaving that theta in degrees, you got to convert it into radians. 4.2 was the start of your unit circle. So you're going to have to be able to find a point on the unit circle. It might be straightforward. It might be like 7 pi over 6, and then it might be like 15 pi over 6, where you've got to find the coterminal point. And then from there, you've got to be able to find the trig functions from the point. So sine is the y, cosine is the x, tangent is the y over the x, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. The calculator part in here would have been like finding the sine of 132 degrees, 41 seconds, 41 minutes, 16 seconds, or the cosecant of that. So you want to be able to do those. That's the calculator part from that section. How do I know if it's supposed to be in degrees or if it's in radians? Okay, degree symbols means it's in degrees. No degree symbol means radians. So this one's going to be in radians and these two are going to be in degrees. Madison, you have a question? No. Well, no. I mean, some calculators, yeah, but not yours. Like yours, you would write sine, and then I go 132. I go second apse. I get my little degree symbol. I do 41 second apse again to get to that angle measurement, the 1 tick mark. And then I would do 16 second, or no, alpha, the plus, is where that second tick mark goes. For cosecant, I would do 1 over and then start all that. So also from this section is if you were given a point, like if it said the point 2, -3 is on your unit circle, find the trig functions. So this is going to the right 2, down 3, closing in that triangle, and then finding the missing side. So 2 squared would be 4, plus -3 squared would be 9, and I'd get the square root of 9, or sorry, square root of 13 would be my hypotenuse. And then from there, you should be able to find all your trig functions. Okay, so 4.3 was your right triangle trig. This is where you were given something like, let's say it said tangent equals 2 over 3. So you would draw out your triangle, opposite over hypotenuse. Same thing here is going to be square root of 13. And then I would find my trig functions based on that. You also had the word problems from this section. Where you had angle of elevation or angle of depression, that kind of thing. So there's one in the quiz again. I'll give that back to you. for 4 was trig functions of any angle. So this was something like maybe they wouldn't be on your unit circle. This would be a coterminal like 17 pi over 4. And it would ask you to find the sine, the cosine, the tangent, the cosecant, one of those things. So this would be the same thing as 16 and 1/4 pi. Not 16, 4 and 1/4 pi. So the even whole numbers are on the right, which would mean this is 2, this is 4. 1/4 would put it in the first quadrant. This would be root 2 over 2 and root 2 over 2. And then you know how to go from there, right? So sine would be the y, cosine would be the x, tangent would be the y over x. This is also where we did the reference angle. So if it's in the first quadrant, then the reference angle is the angle it is. In the second quadrant, I would do pi minus theta, or 180 minus theta. You want the distance between that angle and the x-axis. In the third quadrant, it would be theta minus pi, or theta minus 180. And in the fourth, 360 minus theta, or 2 pi minus theta. So know how to find a reference angle, know how to graph the angles. Or 5 was sine and cosine graphs. So be able to identify the amplitude, the period, the key points, the phase shift, and what to do if you get the phase shift. So after you do the quarter, half, and 3/4 points, you're going to add the phase shift on. And any vertical shifts. And you'll graph one period of these. So there was a bunch of practice in that homework, okay? If you did not apply your best effort on that homework, my advice is to go back through it. You better know how to do all those graphs. We also had a word problem in that section. I think, right, the displacement one, where you had to find, so there's a word problem, where if it said y equals sine 4x plus 8, and it says to find the value, or it wouldn't be x, where when t is at 5, what do you do for those? So if I want to find displacement, and displacement for the y, when t is 5, all I got to do is plug it in. Okay, so an example like this, or a problem like this, sine 4 times 5 plus 8, I don't even know what the answer is, but just so you can get an idea, this would go in my calculator. Would that be in degrees or radians? Radians, okay. And for 6 was tangent, cotangent, secant, and cosecant. So tangent, you're going to set your b minus c equal negative pi and positive, or negative pi over 2, positive pi over 2. And then subtract the period and add the period. You should get 4 asymptotes. Find the point in between for the curve. And tangent goes up, right, down, left. Cotangent, you're setting it equal to 0. And pi, period, still pi over b. Subtracting from the one on the left, adding to the one on the right. Still going to get 4 asymptotes. Find the point in between, but this time cotangent goes up, left, and down, right. And then secant would be based off of cosine. Remember, wherever there's an intercept would be your asymptote, and the arcs go off of that. And cosecant would be off of sine. Again, wherever the asymptotes are, the parabolas would bounce off of that. And then 4, 7 was your inverse function. So for tangent and sine, you would use the first and the fourth quadrant. Sine and tangent. Tangent, you just can't include pi over 2 and negative pi over 2 because it would be undefined. And then cosine would be first and second. So hopefully by now we know the sine and cosines, right? At every over 6, the point would be root 3 over 2 and 1/2. And the tangent is root 3 over 3. Remember, 2 3's make up a 6. At every over 4, it's root 2 over 2 and root 2 over 2. And tangent would be root 2 over root 2 over root 2 over root 2. Root 2 over 2, which is 1. And then every over 3 is 1/2 and root 3 over 2. And my tangent is just root 3. And then all you really need to, like, if you can fill out one of those quadrants, or if you can make a note like that, you don't have to fill out the whole thing. You just need to know your positive and negative signs. So remember, all students take calculus, okay? In that first quadrant, they're all going to be positive. In the second quadrant, just sine and cosecant. Third quadrant, just tangent and cotangent. And fourth quadrant, just cosine and secant. Question on the concepts, because now I've got some practice problems for you to do. We're good? Some of you have got your work cut out for you tonight, I have a feeling. Slackers. I told you not to slack any slaps. This word problem is from 4.4. There's an example in the notes. The very last example, if you want to refer to it, it's like example 11. Jeez Louise, those were long notes. Alright, so what I want you to do is, alright, so I'm going to go over the problems that were in the formative assignment to practice. Number 1 said to find the trig functions of 13 pi over 4. So if you convert that into a mixed number, that's 3 and 3/4 pi. So remember, the odd whole numbers end up on the left. If I go all around, this would be 1, this would be 2, this would be 3. And then 3/4 is past the 1/2 mark, but not quite to the 1, which means it's in the third quadrant. It's an over 4, so I know that it's got the point root 2 over 2 and root 2 over 2. And then if it's in the fourth quadrant, the cosine's negative, but the sine is positive, the cosine, the first way I said it, the cosine is positive, but the sine is negative. So the sine would be negative root 2 over 2, cosine root 2 over 2, tangent negative 1, and then flip them to get the reciprocal functions. For number 2, it said find cosine and tangent if the sine is 5, 6. So if the sine equals 5, 6, this is not on my unit circle, so I need to draw out a right triangle. Sine would be opposite over hypotenuse, and then use the Pythagorean theorem to get the missing side, which would be root 11. And then cosine would be adjacent over hypotenuse, root 11 over 6, and cotangent would be adjacent over opposite, so root 11 over 5. And then we started the graphs. So number 3 said y equals negative 2 sine of x plus 3. The a is negative 2, which tells you that it's going to be upside down. The amplitude is absolute value of negative 2, which is 2. B is 1, which makes the period 2 pi. There's no phase shift, but there's a vertical shift up 3. So I would find the key points by multiplying by a fourth, a half, and 3/4. I get pi over 2, pi, and 3 pi over 2. And then I plot those key points, which are here, here, and here. Add the period for the last one. And then it's sine, so it starts at 0. It would normally go up to 2 and down, down, up. But because it's negative, it switches that so that it starts at 0 and goes down, up, up, down, which was this gray curve here, green curve. And then the shift up 3 means all of those points get shifted up 3 places, which would make that final curve. Okay, number 4 was 1/2 secant of 2x minus pi. So I'm going to first graph y equals 1/2 cosine. 2x minus pi. The a is 1/2, which is your amplitude. The b is 2. Period would be 2 pi over 2, which is pi. The phase shift is a positive pi over 2, and there's no vertical shift. So I find my key points, which are here in the blue first, multiply by 1/4, 1/2, 3/4. And then I take those 3 plus the period and add the phase shift on. So I added pi over 2 to each of those to get my shifted points, which are here. So then I plotted those, start with the phase shift, and then the 4 key points. This time it's cosine, so it would have started at the amplitude, gone down, down, up, up. And then I had to complete the curve on either side to get the asymptotes, which are here. And then draw the parabolas bouncing off of those curves. Okay, then we had, okay, y equals -4 tangent of x plus 1. So this time a is -4, which tells you tangent, which typically points up to the right and down to the left, is going to flip so that it points up to the left and down to the right. And that 4 tells you that your quarter point and your 3/4 point are going to have to be at 4 and -4, which means it's going to be steeper than normal. For tangent, I take the bx minus c, and I set it equal to -pi over 2, and I set it equal to positive pi over 2. And in this case, that would be your bx minus c, which is x. So my first two asymptotes occur at -pi over 2 and positive pi over 2. Then I find the period, which is pi over b for tangent and cotangent. Pi over 1 here is just pi. So from the one on the left, I subtract pi. From the one on the right, I add pi. And I end up with my additional asymptotes. So my asymptotes are here at -3 pi over 2, -pi over 2, positive pi over 2, and positive 3 pi over 2. I've got to find the point halfway between them, which would be -pi, 0, and pi. So I add these 2 points, divide by 2. And then normally my graph would run straight through those. The quarter point would have been at +4 and 3/4 point at -4. But then because of the +1 shift, it shifts that graph up one place, which makes it these curves here. All right, complement and supplement, most of you did pretty good on. The complement, remember, you're going to do pi over 2 minus theta, supplement pi minus theta. So this is 2 pi over 5. If I subtract it, I have to change the denominator, making the complement pi over 10, supplement 3 pi over 5. 7 said to find the length of the arc if your theta is 68 degrees and the radius is 5. So the formula is SOR, S equals theta times the radius, but theta has to be in radians. So the work's done here. I took 68, multiplied it times pi over 180, reduced it to 17 pi over 45, and then multiply it times 5, which was here. 5 goes into 45 9 times, and I get 17 pi over 9. And then number 8 said to find the reference angle. So theta being 265, first to graph that, which if you start in the center position would be here. 265 is just before that y-axis. If it's in the third quadrant, that I do 265 minus 180, and I'd get 85 degrees. And if I graph that, it's in the first quadrant. So all of your reference angles should be less than 90 and in the first quadrant. For 9, you're looking for arc tangent. So you're looking for where on the circle, and tangents restricted from the fourth quadrant to the first quadrant, but the negative angles of the fourth quadrant to -pi over 6, -pi over 4, -pi over 3. And I'm looking where tangent's -1. So if you remember all your over 6's, tangents √3 over 2, over 3. Over 4's are 1, and over 3's are √3. So I know I'm looking for an over 4, but I need it to be a -1, which puts it in the fourth quadrant, which would be -pi over 4. And then the last question was arc cosine, being -1/2. So cosine, we use the first and second quadrants. Over 6's, remember my point's √3 over 2, so cosine would be √3 over 2. over 4s, root 2 over 2, root 2 over 2. So the cosine will be root 2 over 2. And over 3's, 1/2 root 3 over 2. And that's when my cosine is 1/2. So I need the over 3, but in the first quadrant it's going to be positive, which means I'm going to the second quadrant. And the angle in the second quadrant, that's over 3, is 2 pi over 3. All right, hopefully that helps you prepare a little bit more for the test. Remember that there's an extra review on the test assignment itself. Good luck.